Hey, what's going on, guys? Let's do this problem right here. So we have a small a tank right here. So here we have some water. So the question is to pump this water out of this tank, how much work is required, right? So to find this one, what are we gonna do is we are gonna cut a small layer out on the water. So if you see this thin little layer, and take the volume of this one. And if I take the volume, let's say this dV. So since this is small, dV is gonna be width time. So width time length time the height, right? So width time length time the height is gonna be dy. Let's say this small height is dy. So width time length time dy. So that's gonna be the volume. But here we are trying to find the mass, because to find the work we need dw, right? dw is gonna be w is, we know w is equal to force time distance. So force is going to be equal to mg. So therefore we need the mass right here. That's why we are trying to calculate the mass. So what we can do right here is, if we calculate the volume, we can multiply by its density and find the mass. So the dm is going to be equal to volume times the density. So rho w l dy. And width and length is, we know that already, 2 meter and 4 meter. So we can multiply that one right here. Rho times 2 times 4 dy. So that's going to be equal to 8 rho dy, 8 rho dy, and that's going to be the mass. Now let's put all of them in the work equation and find this one. So this is for the small layer. To find this the whole tank, we have to integrate this one. So work is going to be going from, the height is 0 to 3 meter, the total height is 3 meter, h is 3 meter, so it's going from 0 to 3, and dw, right? dw, that is equal to, so here we have the mass. dw is going to be equal to what? dw is going to be equal to dmgy, mass time gravity, acceleration due to gravity times the height. dw is equal to dmg times y, right? So now we can plug this one right here, and then we can find the final answer. And also, if you notice, dm, instead of dm we can plug this value 8 rho dy. So let's write that one first. dw is equal to 8 rho dy gy. So now we have everything in terms of y and these things. So let's plug these things in the equation. This is going to be 0 to 3, 8 rho dy gy. Now except y, everything else is going to be constant, because here we have dy, so we can only integrate the y. So let's move others to the front. Okay, so we have 8 rho g, that is not in terms of y, so we can move that one to the front and integrate this y right here, 0 to 3 y dy. And if I integrate this one, this is going to give us 8 rho g y square divided by 2, going from 0 to 3. Now we can plug the values. So this is going to give us, this is going to give us, land. We have 8 right here, we have 2 right here, we can cancel this one, and this is going to be 4. So 4 rho g and 3 square, and if we apply 0, that's going to be 0. So 3 square minus 0 square, so that's going to be basically just 3 square. So this is going to be what, 4 rho g times 9. Now we can plug the values. 4 times rho is the density of the water, that is 1000 kilogram per meter cube, times the g, acceleration due to gravity, that is 9.8 meter per second square, and then rho g9, right, times 9. This is 9, not g. This is 9 And if you plug all these value in calculator, you will get 352,800 joule, and that is the amount of work required to pump the whole tank out of this tank, the whole water out of this tank. And that's how we do these kind of problems. I hope you guys find this video helpful. Thanks for watching.